Welcome to qnawire.
Let's do this on the decimals graphing calculator. We're going to add a table and give the information from the table of the problem. So we know that the depth was 0, 1, 1, 1.15, 2, 1.6, 3, 2.35, 4, 3.40. With decimals, you do a quadratic regression. Y1 is approximately. Now, a quadratic model is ax squared plus bx plus c. So it would be ax1 squared plus bx1 plus c. We use x1 and y1 to pull from the data titled that in above here. And we use approximately because it's an estimation. So we see this is a perfect quadratic. There essentially is no b with that sort of very small number in scientific notation. Treat that as a 0. So it would be 0.15x squared but x is d, and then just plus 1. When the depth is 2 inches, how far from the base? When the depth is 2 inches, how far from the base can the water stream strike the ground? So you would subtract 1 to both sides, divide by 0.15. 1 divided by 0.15 is 20/3. And so it would be the positive or negative, but we're really not going to go backwards. So we're just going to say the square root of 20/3. And the square root of 20/3, does it say how to round? There's no mention of what you should be rounding to, but we would say about 2.58, or maybe you can say 2.6 inches. We can confirm this with the graph too. If we just graph y equals 2, then we can see that it has a depth of 2 at 2.58 inches. When the water stream strikes the ground 5 inches from the base of the can, what is the depth of the water in the can? Well, that would be substituting 5 for D. So that would be H equals 0.15 times 5, distance of 5, squared plus 1. And 0.15 times 5 squared plus 1 is 4.75. So that would be a depth of 4.75 inches. And that could be confirmed as well if we found x equals 5, then we can see the 4.75 for the depth there.